Hi everyone. It's gonna be a little resonance experiment. This is a circuit I built and coil I wound in series with this small capacitor. That's my scope set at 5 volts per division and the probe at times 10 mode, which means we get to multiply what we see on the screen by 10 to get accurate measuring. And this here is a 9-volt adapter, gonna feed the circuit, and two digital multimeters displaying the voltage and the current I'm using from the grid, basically the adapter. Here with the scope I'm measuring the voltage across the coil, and let's start the circuit. As you can see, the circuit is running now, and voltage is 9.9, 9.8 volts. The current is about 60 milliamps. And oops, here the probe is it's fallen. Trying to attach it back. It's hard to do it with one hand. Okay, I'm ready. And this is the voltage across the coil. It's high voltage. It's interesting that it's above the scale, out of the scale of the scope. I'm showing you that out of the scale of the scope voltage. So this scope have 8 divisions: 1, 2, 3, 4, 5, 6, 7, 8. Basically 8 divisions times 5 volt per division is 40 volts, and probe here is on times 10 mode, which means that the voltage across the coil is 400 volt peak to peak, and even more because I said before it's out of the scale of the scope, and that means it's more than 400 volts peak to peak across the coil, maybe around 450 volts peak to peak. And okay, let's see the power I'm using and calculate it. Let's make the math. 9 9.8 volts times 0.06 amps. It's 0.588 watts, which means it's 588 milliwatts I'm using from the grid. Okay, and yeah, I'm gonna show you the voltage across the capacitor. That's the voltage across the capacitor. It's the same voltage because it's resonance, and when it's resonance, the reactive resistance of the capacitor and the reactive resistance of the coil is equal, and they are in series, so the voltage across both of them is equal. Okay, let's connect back to the coil. Okay. So the coil is in resonance and it's energetic. Here I have antenna coil, radio antenna coil, and LED soldered to it. And when I put it near to the coil, you see that it light, the LED light, pretty bright, I would like to say. Yeah, as you can see, with this small amount of power I'm using, the coil is energized. And, and it's pretty high voltage, you can see. So I can adjust the frequency and get out of the resonance. I can show you that. This is the power I'm using, and let's adjust the frequency. As you can see, the power consumption increase, and I tune it out of the resonance. And back to the resonance here. So, okay, that's it. Thanks for watching.